obviously this isn't ideal, but it'd be better than nothing. What we're going to do first is we're going to review the 30, 60, 90 triangles that you had a little bit of homework on, and we're going to go forward from there. If you remember right, on a 30, 60, 90 triangle, the side opposite your 30 degrees is going to be your x. Your side opposite your 60 is going to be your x on the square root of 3, and your hypotenuse is going to be 2x. Now understand, you'll know that the shorter side is opposite 30, the longer side is opposite your 60. So let's say that we have one to do. And let's say that we know that this is 60 degrees, this is 90, and this is 14 inches. What we would do to find the rest of the triangle, we know that if this is a 90-degree angle, this is also a 30-degree angle. Let me check the camera real quick. Okay. So I'm looking, that 14 is in the position of the hypotenuse. So the 2x is equal to 14, because here's your hypotenuse. That's always going to be your 2x on your 30, 60, 90. So if you solve for the x, you're going to find out the x is equal to 7. Well, remember, the side opposite your 30 is your x, or your 7. The side opposite your 60 is your x on the square root of 3, or 7 on the square root of 3. And then you've solved that triangle. So let's do another one. Still remembering your basic pattern. This is another 30, 60, 90. There's your 90 degrees. Let's say this is your 30 degrees, and this is going to be 4 on the square root of 3 over 3. Well, you know your side opposite your 30 is equal to x. So I would turn around and I would take this x and I'd multiply it by 2 to get the hypotenuse, or the side opposite your 90. So 2 times 4 on the square root of 30 over 3 is going to give me 8 on the square root of 3 over 3. So that would be that side. Then, well, actually no, that's going to be this side. This is going to be my side opposite my 60. No, I had it right the first time. Okay, so this is 8 on the square root of 3 over 3. Your side opposite 60, remember, is x on the square root of 3. So this is my x again. So I have 4 on the square root of 3 over 3 times the square root of 3. Square root of 3 times the square root of 3 is just 3. So 4 times 3 is 12. 12 over 3 is going to give me 4. So the side opposite my 60 would be 4. All right, let's do a 45, 45, 90. Remember the pattern here. The sides opposite your 45 are x's, and the hypotenuse is x on the square root of 2. So let's say I have this one, where I have a 45, and then the hypotenuse is 8. Well, in order to find what x is, I would have to put the hypotenuses together. So I have x on the square root of 2 is equal to 8, and I'm going to solve for x. So I'm going to divide by the square root of 2, divide by the square root of 2. Remember, you cannot leave the square root of 2 on the bottom. So you have to multiply the top and the bottom by the square root of 2, which is going to give me 4 on the square root of 2 over 2, or 8 on the square root of 2 over 2, or 4 on the square root of 2 as your x. Well, this is x and this is x. So this side is 4 on the square root of 2. This side is 4 on the square root of 2. And then you've solved that triangle. Sometimes it looks a little bit more complicated than this, so let's do a more complicated one. Got a lot going on in one problem. You basically have several triangles. This is a 60, This is going to be 10 on the square root of 3. This is going to be a b that I'm trying to solve for. This is 30. And the whole thing across here is going to be c. And this right here is going to be x. So I want to solve for all of my unknowns. Now, I can break these into smaller triangles. I can also look at it as a bigger triangle. So if I look at the bigger triangle, I've already got the x. The x is 10 on the square root of 3. So across from 60 would be 10 on the square root of 3 times the square root of 3. Because remember, the pattern is x on the square root of 3 is opposite to 60. So square root of 3 times the square root of 3 is 3. 3 times 10 is 30. So that's going to be 30 right there. Now, I can solve the c by using Pythagorean theorem. So I've got 10 on the square root of 3 squared plus 30 squared is going to equal my c squared. So I'm going to pick up my calculator. And I'm going to have 100, because it's 10 squared, 100 times 3, because it's going to be the square root of 3 squared. So that's going to be 300 plus 30 squared. So I have 1200 is equal to c squared. So c is going to equal the square root of 1200, which is going to give me a decimal value of this. But I can also break it down by maybe dividing it by something I know I can take the square root of. So 1200 is the same thing, the square root of 1200 is the same thing as, let's say 400 times square root of 3. So square root of 400 is 20, so I have 20 on the square root of 3. Okay, so that is going to be my whole c, is going to be 20 on the square root of 3. Well, now I have to come through here and I have to solve for part of this. Well, I can look and I can go, well, that's going to be a 30 right here. So I've got my hypotenuse, which on a 30, 60, 90, 2x is equal to my hypotenuse. So I'm going to divide by 2, and I'm going to get x is 5 on the square root of 3. So that's going to be this right here, just looking at this smaller triangle. And then I'm done solving it. So you can see that you use several different things, Pythagorean theorem, plus your 30, 60, 90. Breaking up your triangle into two 30, 60, 90s and the larger one to find all of your unknowns. Then you turn around and you put these things on a coordinate plane. So let's say on a coordinate plane, I'm going to have to switch pens. I've got the point 32, that's my C, and I have the point 92, and that is D, and I want to know what my value up here is for P. And what they've told me is that this is the longer side of my triangle. So that's going to be across from my 60. They tell me it's a 30, 60, 90. And I'm going to need to know what this value is and what the ordered pair is. So I can sit here and I can tell you what the side opposite my 60 is. I could use the distance formula, but I don't need to because it's horizontal. So the difference between my x's is going to be 6. So that has a value of 6. So x on the square root of 3 is equal to 6. So when I solve it, I'm going to divide by the square root of 3. and then I will have to rationalize my denominator. So I have 6 on the square root of 3 over 3, or 2 on the square root of 3. So that's going to be my x, or my value right here, 2 on the square root of 3. So what I can do, if I need to know that distance, PC is equal to 2 on the square root of 3, but then I would just turn around and I would add that to my y value. So my x value is still 3. My y value would be 2 plus 2 on the square root of 3. And you could give a decimal value for it, but you don't need to. Let's do another one of those. Let's say I have a 30, 60, 90. And they tell me that my right angle is at B. I have the point A right here, which is A0. And I have the point A3, 8, 3, which is B. And I know that that is my right angle. And I know that AB is the shorter side. So that is going to be opposite my 30 degrees. And that other one, I guess we could say that that's longer. I don't know where it's going to land over here. That other one's opposite my 60. So I would have to know that x is equal to the side opposite 30, according to how everything's related. The difference between my y's here is 3, so this is 3 units. So therefore I can go back and I can go, well, this is going to be 3 on the square root of 3. So whatever value this is, let's say we call that c. The distance between c and b is going to be 3 on the square root of 3. But the ordered pair that represents c is going to be, if you will, 8 minus 3 on the square root of 3, because I want to back it up, however that many that is. And the height of it is going to be the same as this. So the y value is 3 right there. All right, so that finishes up section 7.3. Section 7.4 starts our trig section. Now remember, trig is the math of comparing angles to sides. You have had this before, so a lot of this should just be review. But you're going to need to go back and memorize some stuff that hopefully is in your memory somewhere. You just need to bring it to the forefront. The trig is all based on a right triangle. And we have an abbreviation that helps us remember stuff. SOHCAHTOA, if you remember. So the S stands for sine. And sine is your opposite over your hypotenuse. Abbreviation SIN. Cosine is adjacent over hypotenuse. Abbreviation COS. Tangent. Abbreviation TAN is opposite over adjacent. So you can see that these come from that. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. So if you have an actual triangle that is a right angle, and I want to know the sine of angle A. That means I'm standing right there at angle A. Now I've got some values here. So the sine of angle A means I'm standing here. The opposite side would be this one, which is 3, which means if I'm standing at A, I cannot reach out and touch it. The hypotenuse, side opposite your right angle, is 5 on this one. Cosine of angle A would be adjacent. I can reach out and touch it, but it isn't the hypotenuse, of 4 over 5. And the tangent of angle A would be opposite over adjacent, which would be 3 over 4. But let's say I want to know the sine of angle B. Well, that means I'm going to run over here and stand at angle B. So now my perspective is different. Let me give myself some space here. So if I'm standing here, opposite over hypotenuse is 4 over 5. Cosine of angle B is adjacent. Remember, I'm standing here, so adjacent over hypotenuse. And tangent of angle B would be opposite over adjacent, or 4 over 3. So it's all perspective of where you're standing. They're never going to ask you for these based on the right angle. You'll always be at one of the other two angles. So you should be able to do this for any triangle that you have. If they asked you what the sine, the cosine of the angle is, you should be able to come up with it. Sometimes they give you two values of a right triangle, and you have to find the third side by using Pythagorean theorem before you can ever do any of this. Now remember, you cannot have a square root left on a bottom. So you have to rationalize the square root if it's left on the bottom. Sometimes on this, all they're wanting you to do is pick up your calculator and give them concrete values to the 10,000th mark, which is 4 places after the decimal. So let's say they give you something like this. The cosine of 39 degrees. All I have to do is I have to pick up my calculator. Now it would be most helpful if you make sure it's in the right mode. So if you go to mode, go to the third one down, make sure that it's in degrees. Then you can go second quit to get out of that after you've selected degrees. Once you have it in degrees, you don't have to change it again. So I just do cosine 39, because you get a cosine button on your calculator, and then I have to round it to 4 places after the decimal. So pick up your calculator and make sure you can do that. The sine of 67 degrees. Again, calculator use, sine 67, hit enter, and you're going to get decimal 9205. Make sure your calculator is set up correctly to do that. You can use all this trig stuff to find unknown parts of a triangle. So, for instance, let's say I have this triangle, and they tell me that I want to solve it. So, I've got 56 degrees here, and maybe this time you know that side, and you don't want to solve the whole triangle. Let's say you just want to solve for x. So you go, I'm standing right there because I know that angle. I want to know opposite, and I have adjacent. So what compares opposite and adjacent? Oh, that's tangent. So I go, the tangent of 56 degrees is equal to opposite x over adjacent, which is 97. Now I'm just going to use algebra to solve this. I'm going to multiply both sides by 97. Okay.